All right, welcome back to Computer Science E76. My name is David Malin. I will be with you for the next several lectures as we dive into iOS. So whereas many of you probably started the semester with a bit of familiarity, at least with Java and the like, odds are fewer of you are coming into the course with familiarity with Objective-C, the language of choice for all things iPhone and iPad development. So we're going to dive in today with both that language as well as with some of the frameworks that Apple specifically provides for those devices. But we'll start with a provision of resources. So you will see in the course's syllabus that we have 3 books that we recommend at this point in the semester. The first of one of which is here. ISBNs and titles and such are all listed in the syllabus online. So just to set your plans in motion in your mind, realize first, Apple provides a significant amount of documentation online, some of which we'll walk you through, some of which we'll just point you at, some of which you'll hopefully explore on your own. You'll find that it's not necessarily ordered in the most obvious way as to which documents you should start with first. So what you'll find in the first project, which went online last night, the iOS setup project, we'll try specifically to say at times start with this, then that, and then kind of leave you off on your own. With regard to these books, if you are the type of person who finds him or herself comforted by having a text, or you like the table of contents index and you just like having that as a resource, realize that there's 3 books that we'll whirl through in just a moment that we recommend. The only caveat, even though 2 of these just came out like 3 or 4 weeks ago, all 3 are out of date already. Just a week or 2 ago, Apple released Xcode 4, which is the latest incarnation of its IDE. This is the Objective-C counterpart, if you will, to Eclipse, which you've been using for some time. For the most part, it's Xcode 4 is better in that it integrates into just one utility a few features that were scattered among a couple of utilities, one of them called Interface Builder. So you'll see these words a lot in print. You'll see that the book tells you to do things like spawn Interface Builder, which actually no longer exists as of a couple of weeks ago, at least with the latest IDE. So you'll find that the books are still good resources, but you're very much cutting edge now at this point, where things are changing out from under us quite quickly. In fact, I suspect tonight's lecture will be out of date by next week, but we'll do our best to stay ahead of the curve. And this is only to say, to be honest, as you're exploring resources online, even some we might have recommended to you in PDFs, just realize that sometimes your expectations might not align with the text just because things have changed. So don't freak out, but just be mindful of the fact that maybe you need to update yourself. Now, with that said, you'll find an inordinate number of free resources online, but they're of varying quality, I would say, at least if you find them by way of Google. So what we've done over the past couple of weeks is augment the resources page of the course's website, and you'll find a pretty substantive iOS section here. Read through these at your leisure, and you'll find that these are resources that we, the staff, have found pretty good, and we cite specific excerpts from those in this first project as well. You'll also see atop this resources page that the 3 books that you're about to see pictures of actually come with all of their source code online, errata if applicable, and some other resources. So realize there's some pretty good resources there too, and certainly check out Amazon or the like to find them at perhaps reasonable, though maybe not yet used prices, since most of them did just come out recently. So with that said, my personal arbitrary opinions on these texts, I actually really like this book because it's in full color. It's actually just pretty to look at. The code is syntax highlighted in the books itself, but it's also written with a broad audience in mind. To be honest, there's not much talking over one's head. It pretty much walks you through a good number of examples, albeit in a manner that's a little now inconsistent with the latest tools. So you'll have to kind of make some mental leaps there. This book is very well known. It's a black and white book, sort of old school style, but it too is sort of very similar in spirit to a text that takes you from nothing to something by the end of the book. But this one, I would say, assumes a bit more of the reader. Read to me, at least, a little more technically. Then there's this third book, which I've also liked in that it presents each chapter or section as here's a problem, here's the solution. So it provides you with a bit more of a bite-sized chunks of things you might want to do in the iOS environment, and here is how you do it. Whereas those first 2 books are more of a hand-holding, read them from start to finish kind of walkthrough. But technically, you don't need any of these books. They are only recommended by the staff, and you will see online that there are innumerable resources ahead. In just a bit, too, if on your mind is this question of, do I have to buy Xcode? Where do I download it? What's this university program? We'll come back to that quite quickly this evening. But any questions before we now dive in to this new world? No? All right, so Objective-C is indeed an object-oriented programming language, and it's a superset of an older language called C. And so rather than dive into Objective-C directly, a nice way to build up is to do a quick tour for those unfamiliar with C specifically, because you'll actually see that even though Objective-C will hide some of these details, as we'll begin to see tonight, you will occasionally see, even within Apple's frameworks, within sample code, you'll see a commingling of what we'll soon understand to be Objective-C syntax, but also C syntax. In fact, a lot of the graphics libraries that are available on the iOS and well as Mac platform are in fact still C-based, so you'll see a mixture of syntax. So it's okay if you, at least at first, conflate the two, but for now you'll see that C is actually a pretty small language, such that in just a little while here we can tour through most of the language. So here is Hello World written in a language called C. So a whirlwind tour here, but I realize some of you might have seen a language like this, some of you might have not, so please at any point, no dumb questions, just raise your hand, look a bit confused, and we'll pause, explore that topic, and then move on. Honestly, there's no point in my being here if I'm just talking and at least a non-negligible number of you are not absorbing. So please help me fix if I go astray. So quick whirlwind tour, then we'll actually start playing with code like this. At the top of the file is something similar in spirit to Java's import statements, whereby sharp include is what's called the preprocessor directive. Most of this jargon, most likely you won't need to retain, at least just to get going with this next segment of the course, but so that if you see it in print or online, realize that these are, I'll try to name drop the jargon that's relevant. So there is a file somewhere on my computer called standardio.h. This is what's called a header file, and in a header file are things like, here are all of the functions that I am going to use in my following program. You might have data structures that you might want to define, constants that you might want to define. In the world of C and C++ and Objective-C, you typically factor those out to a .h file, especially if you want those declarations to be included by multiple source files, multiple C files, or multiple .java files, if you will. And we'll see this in a number of examples. Here is, much like Java, it has sort of a cryptic declaration of a main function. Int means main returns an int. Generally, a program will return 0, and that means all is well. If it returns anything other than 0, that generally means something went wrong. Int argc here is just like Java. It's going to be the number of command line arguments passed to the program. And now the syntax gets a little crazier, as we'll see. Const char star argv. The star is something called a pointer, but we'll come back to that in a moment. And that's going to be, as suggested by the square brackets, an array of command line arguments. So the rest of it, to be honest, is probably pretty self-explanatory. So printf is sort of the most, say, familiar function that you might use in C, simply to print something to the command line. But for now, just get an aggregate sense of the syntax that we're going to use here. So how do you go about writing a program in C? Well, you know what? I can simply go ahead and copy this. I'm going to open a program on a Mac called Terminal. For those who come from more of a Windows world, this is like the old school DOS prompt or command prompt these days in latest versions of Windows. I'm going to go ahead and just open a simple text editor like TextEdit. It's called VI or Vim on a Mac. And I'm going to go and do something like hello.c, paste that in. This is now just a text file. And I'm going to run a command like gcc hello.c. No error messages means all is well. And that by default created a file oddly named as a.out. And if I hit if I run that program a.out, voila, we now know C. All right, so we'll go into a little more detail and things that will help us with Objective-C. But any questions on just some of the rapid-fire preliminaries? No? All right, so all of the code, incidentally, if you didn't pick it up, is available in alphabetical order in tonight's handout, as well as available online. So we're not going to play around much with the command line, certainly not in the Mac world, where Xcode is really the environment that you use to write code. You can get away, in theory, with using other tools, but this is really the thing you should be using, in that everything is nicely integrated. Yeah? Sure. So argv is argument vector. This is an array of command line arguments, which in almost any case I can think of moving forward is going to be irrelevant to us, because we're going to be running GUI-based applications that aren't run at the command line. But if I had written something at my blinking prompt like a.out and then foo, bar, baz, those three words, foo, bar, and baz, would be tucked inside of that array called argv, so that my program could use that information if it wanted to. Oh, the asterisk it denotes something called a pointer, and that's actually a juicy topic that we'll spend a bit more time on in a bit. So that's an allusion to passing by reference, passing by address, as we'll see. And C hides these details a lot less than a language like Java. All right, so we're not going to play around so much at the command prompt, but that does suggest that you can use very limited tools and to actually start writing in this kind of language. But what we're really going to use is Xcode. So Xcode is the counterpart in this world of Eclipse. Up until 2 weeks ago, it was free. Now it's $4.99. So a quick word on this, particularly as it relates to what you'll do over the next week or two in setting up your own Macintosh. So per the syllabus, for the next 5 or 6 weeks, you will indeed need to own or have or borrow or have access to a Mac. This can be your own, a friend, something at work, or worst case, for those of you local to campus, at 53 Church Street, there's a computer lab with a few dozen Macs, all of which will have all of the tools that you'll need for the course installed on them. And there's instructions in this week's PDF for the iOS setup project as to where to go, how to get access, and what the hours are for the lab. So right there in the specification. Give them until the start of next week, though, to get the latest version of Xcode installed. Right now, they're still running the previous version, which you're welcome to use. But if you want to just avoid silly hang-ups mentally, just wait till they get that installed. Once you have procured yourself a Macintosh in some form, you will need to download, as you'll see in this week's spec, a program called Xcode. So this is now available through what Apple recently launched called their App Store. This is for Mac programs, not just iPhone and iPad applications anymore. The PDF will walk you through all of these steps, but it will indeed cost $4.99, even though we're part of what's called the university program. So the one gotcha with iOS development is that whereas in the Android world, if you owned an Android phone or tablet, you could just install your APKs or the like right onto the phone, and you were off and running with a USB cable or whatnot. Well, that's almost the same in the iOS world, but you need to pay for that ability to actually install the software that you write onto even your own personal iPhone or iPad. We are part of what's called the university program, though, which means you don't have to pay for that as students. In the next project, we will walk through the process of actually installing code, not just in the free simulator, but also on your own phones if you own such or have friends' hardware that you want to install on. And you'll see that it also involves digital certificates and the like. So it's a bit of an involved process. The gotcha, though, is if by term's end, I feel like I'm issuing all of our legal disclaimers here, but the gotcha is that if at term's end, you want to submit one or more of your apps from the course or after the course to the App Store to sell them for free or for 99 cents or whatnot, at that point, you're going to have to convert yourself from a university student to an official iOS developer. And we also describe that process in this week's PDF. So in short, you do not need to pay $99 to become an iOS developer for the course. You do not need to pay $299 to become an enterprise developer for the course, but you will need to pay $4.99 to download the IDE called Xcode 4. And do, in fact, download the latest, as you'll see that it is improved overall, I'd say, versus the last version. And it's what you're going to start to see all the documentation online for anyway. So we're not going to spend too much time on the interface of Xcode today. Much like Eclipse, there's a lot there. And to be honest, if you're coming from the world of certainly Notepad or Vim or Emacs, it actually can be a bit overwhelming at first. But consider this a cheat sheet. It's excerpted from Apple's own documentation. But what we'll do in lecture tonight and in the projects, as you'll see, is we'll hold your hand as best we can through the various things that you should care about. And then eventually, presumably, you'll acclimate to other buttons and icons that might be ancillary to the challenges at hand. So what do we got here? And documentation. So everything, all of the documentation for what we're about to dive into is freely available online in the form of web pages. But Apple also has a tool built into Xcode called Organizer, one of whose tabs we'll see is called Documentation. And that tab essentially links to that online documentation as well. So it's pretty much the same as you would see in the web interface. And it's akin to JavaDoc or the like in the world of Java programming. All right, so again, if any of that was a little quick in terms of where do I go to download it, what do I download, again, the iOS setup spec will hold your hands through that. Yeah?
I have a question. Like 2 months ago, I downloaded Xcode
Mm-hmm.
and I installed Xcode. So it means that right now I have to go back, download the 2 gigabytes again. Of
Oh,
the new
4 gigabytes now, but yes. You will, yes. So even if you have Xcode 3, unless this is going to prove a huge problem with work commitments or work environments like that, we would strongly recommend that we get everyone on the same page now with Xcode 4 moving forward. What you'll find is when you download the installer, it's about 4 gigabytes now, you will download an install xcode.app file to your hard drive. You double click it. It will say, I notice you have Xcode installed already. I am going to rename your developer folder to developer-old, and your old installation of Xcode 3 will stay in that folder. But yes, you will need to download, because it literally, at least the official release just came out a week or 2 ago now. All right, and I'm sure by semester's end we'll have to upgrade to something else. All right, so you'll find in C, so we'll focus first on C, which is a subset, as we'll see, of Objective-C. There's a lot of C's. Primitive data type. So you'll see the familiar chars as we move forward. Doubles, floats, ints, longs, unsigned ints, and ... There's a bunch of others, but odds are from any typed language with which you have experience, most of those primitives are familiar. They're primitives in the sense that they are native to the language, and they usually take up 1 to 2 to 3 to 4 to 8 bytes of storage space, which we'll see over time. Printf. So printf is the function we'll see, at least for now, for the next few minutes, in the context of C. We'll transition to another function, which is sort of the poor man's debugging tool in iOS called nslog, which will have a similar effect, but will also use some of these shortcuts. So much like the printf function in system.out in the world of Java, you can similarly format strings in the world of C. And so if you want to write a program that prints out a number or a string, but you don't necessarily know what that number or string is going to be in advance, and you want to put a placeholder between quotes to say, put a variable's value here, you have these format codes. So %s is for string, %d is for decimal integer, %lu is for long unsigned integer, %lld is for long, which is generally 8 bytes, decimal integers, %f float, and there's a whole bunch of others. But we'll see these in the world of nslog as we play more with Objective-C, because it's useful for printing out debugging information. But we'll see an example of that right now. So I'm going to go ahead and do this. You have this among your printouts for today. Some of the source code examples we'll just glance at or fly through, since the programs are super simple, but I wanted to make sure that you had at least a compilable, runnable piece of sample code, so that after tonight you can go back and play, and we're not just looking at it on uninteresting black and white keynote slides. So I'm going to go ahead and open up this program called Xcode. If you'd like, I'll point out which file this is going to be in a moment. And the very first time you run Xcode, you're going to see a little splash screen like this that says you can create a new project, connect to a repository. The latest version of Xcode has support for Git repositories and the like built in. Learn about Xcode, go to Apple's developer portal, or you can kill this thing altogether. So right now, I'm simply going to go up to the File menu. I'm going to go up to New, and I'm going to go to New Project, and you're going to see a bunch of options. And most of these we're going to ignore for just now, but let's at least do a quick tour so that you at least know what's coming down the pipeline. So I just went to New Project, and again in the spec, we'll always walk you through this initially. It looks like Xcode comes with support for developing iOS applications at top left and Mac OS X applications at bottom left. So these are just templates. You don't really need any of this screen to actually start writing software, but the reality is almost all of you in Java have always probably gotten a little annoyed writing something stupid like public, static, void, main, int, args, all of that nonsense. So what Apple's tried to do in their IDE is just make it easier to get rid of some of the minutia. And if you're using the same kinds of, the same framework, the same template all the time, that's all these icons are. They're just going to pre-populate this thing called a project with a bunch of sample files that you can then start to gut and customize to your content. So at the top left, we'll dive into these before long, but you'll see as a teaser that there's different types of iPhone applications or iPad applications. And if you're an owner of one of those devices, you'll probably see some familiar icons here. At top left, what they call a navigation-based application with the back button, the forward button, those kinds of things. That icon might look a little familiar. Tab bar applications at top right. Split view-based applications, which is applicable to the iPad environment where you have more screen real estate. The simplest of these templates, though, as we'll see in a little bit, is going to be this one, which gives us some sample code, but not a huge amount, but it's enough to actually skip some of the minutia of things like int, argc, argv, and the like. But we're not going to go there just yet. And we're not going to go in deeper to framework and libraries if you're doing things a little more sophisticated in this platform. If you really want to start from scratch, there's just the empty template. But for now, because we're playing with C, just to get acclimated to the environment, we're going to actually write a quick Mac OS X application. So this is a program that's going to run on my own laptop. You can follow these steps along at home too with the code that's printed. And of these options here, Cocoa application, Cocoa being the framework with which you generally write Mac software these days, graphically based, we're going to keep it super simple, and I'm going to choose the template for command line tool. So this is going to be akin to just wanting to write something like hello world. So I'm going to tell Xcode I want the command line tool. I'm going to click next. I now have to choose a product name. So I'm going to call my product hello C. You'll see that I can specify different variants of this template. Do I want some sample C code, sample C++ code, sample foundation code, which we'll see in a bit. But for now, I want to keep it super simple and just choose this language called C. I'm going to go ahead now and hit next. And now I'm going to have to specify a location. To keep it simple, I'm going to just put this on my desktop. I'm not going to bother creating a source control repository. I'm just going to leave that unchecked to keep it simple. I'm going to click create. And now I'm overwhelmed with the interface here. So let's do a quick tour of what we should care about for now, but we'll try to home in on just the things that are interesting at this point. So you'll see, and I'll make this bigger in just a moment, they've kind of made Xcode look like iTunes, if you're a user of iTunes, where now it's ever more fun to run your code because it's a big play icon at top left there and a big stop button when you're tired of listening to your code. At top left here by default, notice that I have a little project navigator or folder navigator where I can see all of my files. And so when I said that we just used a template called command line tool, that has given me a bunch of files, namely main.c, which is going to have some hello world-like code, helloc.1. That's going to be a template for what's called a man page or a manual page in the Unix world. We're going to ignore that altogether, but it's when you want to have command line documentation. It's just template code there. And then you have these folders, but it's worth noting that in Xcode, even though they're using this folder metaphor, those are not necessarily folders on your hard disk. They're what Xcode calls groups. So there's this feature in Xcode whereby if you just want for your own sanity to cluster similar files together, and you really shouldn't need to care about where they are on disk, you can put them into these things called groups. So this template has just taken it upon itself, because some Apple developer decided this, that we're going to put the code in the man page in a hello C group, and hello C, the product, the application I want to build, is going to go into that products group. Now, what was I actually handed here? Well, a whole mess here on the right-hand side. This is a bit overwhelming on the right, but these are all of the various build settings. So generally, when you write Java-based code, at least at the command line, it suffices to run javac and then your source code name, or Java and then the class name. And you don't have to really worry about a lot of these questions. Well, even at the command line, there's those things called switches or options, where you can control the behavior of the compiler or the runtime. Same deal here, but much like Eclipse has, you're just looking at a graphical representation of various settings that you can tinker with, but at least for now, will rarely need to touch. So for now, I'm just going to wave my hands at that. You're welcome to tinker, but I would suggest always saving before you start tinkering and changing, lest your code stop working and it be hard to figure out what you did change. So let's focus only on the juicy stuff now. Let's focus only on the code. So at top left, I've clicked main.c. And hello world has never been easier to write, because it seems that it's been written for me already. So again, I chose my command line tool from the template, and Apple has already written for me in this language called C a little program called hello world. And you'll notice a few, let's see, interesting details. Even among this template is some stuff at the top. It seems to know that I'm logged in as Malin, but Malin does not seem to own a company, so that's just a template placeholder. I'm going to wave my hands at how to customize that, but it can be customized if you like. But for now, it would just be easier for us to change those comments atop the file however we see fit. So let's run this. We're not going to use terminal anymore, the little blinking prompt, the command line environment, but let's see what else there is in Xcode that I probably should care about at this point. They've simplified the interface. Your version will not have the little colored markers and erasers up top. That's a different tool there. But there's not much going on there. But what happens with Xcode 4 now is that when you start to click various icons, more and more complexity or features start to get revealed. So let's take a look at top right. So at top right, you will see a whole bunch of icons or buttons that are going to control in a moment what the editor can do for me. And if you start enabling all this stuff, it's going to get super complex, super fast. So let's go ahead and turn on everything, including the pane over here, or rather the assistant editor, which we'll come back to in a future lecture. Let's turn on the bottom view, the right-hand view, and so now I've got a powerful IDE of some sort here. Now on the right-hand side is going to be some juicy information once we start wiring together iPhone applications. For now, there's not much of interest over there. What's kind of neat about Xcode 4 is that right now there's no assistant results, but generally if you open like a .h file, that I alluded to earlier, Xcode will do its best sometimes to guess what other file might you want to look at the same time, and it's going to put it in that pane for you if you have that feature enabled. What you'll see too in Xcode 4 is that Apple has transitioned from the default GCC compiler to the LLVM compiler, which is reputed to be much faster, but also more helpful when it comes to error messages. So you will find, too, that even before you compile code, you're often shown either in yellow or red definite errors or possible errors. So what's nice, too, about Xcode 4 is that it's really going to ideally push you toward writing code even more proactively before you might realize that there's some room for improvement there. But for now, let's keep this simple. I'm going to go back to my single editor view. I'm going to turn off all of the distraction on the right-hand side, but I am going to leave up the bottom side. So much like you have console access and other IDEs, in a moment, because this is a command line application, my output's going to end up at the bottom of the screen. So I'm going to hit the little iTunes Play icon at top left. Because this is a template, there's something called a makefile or settings already pre-configured. So Xcode knows how to compile this simple program here. And notice there's a whole bunch of mess here alluding to a program called GDB. Those familiar with the Unix or Mac world will know that's the GNU debugger, which we will start to use. For now, there's not much to debug, but in bold is my output. So indeed, when I run this program, I see hello world down here. And so now I clearly have the ability to generate output to the screen. So let's now start to use, say, some variables. I'm going to go ahead and gut this program and get rid of this. And just in between the prompts here, I'm going to do something simple. I want to just use printf in a little more interesting way. So I'm going to go ahead and do this. Int x, and this is just going to take on the number 1. And then I'm going to print out the value of 1 in printf. So printf %d \n for a new line, and then that %d stands for, quick sanity check, even though you might have seen this in Java. So decimal integer. So if I want to plug in the value of x there, I simply plug in x, semicolon. I'm going to return 0 as a matter of convention, and you'll see that Xcode will nag you about some things that you might have otherwise taken for granted. So I'll get in that habit now. I'm going to go ahead and recompile and run with that button, and indeed at the bottom in bold, I see the number 1. So syntactically, there's not all that much new here just yet. So let's see what more there is to this language and its superclass. So there's the notion of casting in C as well. Yeah? Absolutely, yes. So just as we could print literally the word hello world a moment ago between those quotes, similarly could I say x equals %d. I could save this, recompile, and now I would see literally x equals whatever the placeholder's value is.
So what is that % d there?
%d is telling printf, I don't know what, at the night I wrote this code, I don't know what the value of x is, and so I want printf as its second argument to take a variable in and then do that substitution for me. Find the value of this symbol called x, plug it in here, and then output a 5-character string that says x equals 1 \n. So it's just a placeholder. It says put a variable's value here, and we can do this slightly differently. If I had a string like if I had a number like a floating point number, which is something with a decimal point, let's call it pi equals 3.14. Here I could say something like pi equals %f, plug in pi, and now it's going to do the same insertion of that value. But if I now hit run and watch the output at the very bottom of the program, I'll see that pi is apparently not just 3.14, it's apparently 3.14000, which isn't quite true, but the %f by default will show you 6 decimal points of precision. It would truncate the decimal point and treat what's a floating point value as a decimal integer. Exactly. Yeah?
Would it cast it, or would it force you to get garbage by hanging it as a
So that would be OK too if I wanted to cast this to an int. Oh.
If you change the f to a d.
OK, let's try that. So let's go ahead and rerun this. And in fact, now we have this funky representation. And this is because the pattern of bits that are being used to represent that floating point value are now being misinterpreted as representing an integer, which uses those 32 bits or 64 bits in a different arrangement, in a different way. OK, so notice this, though. So now already my code's apparently getting pretty bad. And this is frankly some of the utility of Xcode 4. Unused variable x, it noticed that. So that was kind of dumb of me to declare that. It's specifying that I wanted an int, but I used a double. So these are the kinds of warnings that will hopefully guide you toward writing better code. And certainly when it comes to the projects, if you've submitted very proudly your assignment, and we open it up and we see a lot of yellow, not the best place to have left it off. At least take Xcode suggestions when it comes to warnings or errors. Yeah?
Would you say it's not as sensitive as Eclipse? I mean, when you took everything out, you didn't have the return in there.
Let's see. So I added it back before I ran it. So if I fix this, let me go back to printing out the value of pi with %f, and now go ahead and run it. So we're gone. We have no more yellow warnings. And let me see if it actually nags me about this one here. So here, in fact, it's OK. Xcode doesn't mind this. By default, main is declared as returning an int, and 0 is going to be returned sort of automatically by default for me. All right. So just some of the basics. Now let's start introducing some of the features of the language. So much like Java, there's this ability to cast. We can use casting to convert from a float to an int. If you want to take 3.14 ... to just 3, we could cast it to an int and throw away some of that information. But the casting, these parenthetical casts, are going to get more interesting when we get to Objective-C and objects, so that when we start talking about, again, the notion of inheritance or polymorphism or hierarchies of classes, we'll be able to explicitly tell the compiler or runtime, I know that this class is a subclass of another, so behave in a slightly different way. But you've seen that in Java. So pointers is where now the conversation can get a little interesting and pretty different from Java for just a moment. Thankfully, Objective-C is easier with regard to memory management in some ways, but it still leaves a lot of the control of your use of RAM up to you. So what do we mean by this? Well, these are other data types in C. Anytime you put a primitive's name and then a star, you are saying this isn't a char anymore, or a double, or float, or an int. This is a pointer to a char, a pointer to a double, a pointer to an int, or the like. So now what is a pointer? A pointer is just a memory address. So in C, you have the ability to go to any one of the individual bytes in the 2 gigabytes of RAM that might have been allocated to the program that you wrote. This is wonderfully powerful in that C is about as close to assembly language as you can get. You can do most anything you want with the contents of your RAM and jump around here and here and here, but it also hints at the dangers of writing software in C and C++, because if you don't know what you're doing, or if you're a little lax with regard to security, or you just have written some buggy code, you can make yourself vulnerable to something called buffer overflow exploits, which are very easy in the context of C and C++ and a few other languages. Java does not have that same vulnerability because you, as a Java developer, do not have direct access to memory. In fact, if you ever try to take a reference to a Java object and print that reference, you usually see like a hexadecimal number or something with an @ sign or the like, and that's essentially a hash value of an address. It's an obfuscation of the address. It means you cannot touch, or you don't even know where exactly in RAM that is. Now, why do we introduce this here? Well, C, and in turn, Objective-C does support pointers. And so as soon as we start creating objects in memory, we'll create an object today that represents, say, a student. Next week, we'll create an object that represents a window in an iPhone screen, or a button on an iPhone screen. Well, you're going to need to pass those kinds of objects around in memory, and you're going to still do that by way of these things called pointers, or their addresses. So let's see how, in fact, pointers are useful. Rather than write this one from scratch, I'm going to go ahead and open Xcode, and I'm going to turn our attention to a project rather, called swap failure. So I'm kind of spoiling what's about to happen here. I have written some buggy code, and among your printouts for tonight, you'll see when you scroll to the S section, a program called swap failure. This is just another command line tool that I wrote. So I started with the same exact template. I actually manually deleted that .1 file, the man page, because I didn't need it. I'm not going to bother documenting this for the command line usage because they're so short and no one's going to ever run it. So I only have, notice at top left there, 2 files. I have one, main.c, which is where my code is about to be. And then in red, swap failure. Swap failure is the name of my program, and it's in red because I haven't compiled it yet. So it doesn't literally exist on disk. It will become black once I've compiled it, and there's a binary I could double click on disk. Question in the middle.
When you say open, do you open that file or you open that project? Does it save the previous environment?
Excellent question. Almost always in Xcode, you're going to want to be in the habit of opening entire projects. And inside of a project are multiple folders, multiple files that might be arranged with these things we called groups that pictorially look like icons there, look like folders, but they are in fact just these meta groups. You can in fact open files with Xcode, and that's useful often if you want to just open some arbitrary file, maybe from another project, and import it or the like, but almost always get into the habit of opening and creating new projects and then create new files within those projects, which we'll do before long.
Reference while you're working. If you open a new file, it wouldn't add it to that project. You just want to see the file.
Correct.
Close it up.
If I simply hit Command O or go to File Open, it would open a file, but in a separate window. I would have to drag, the easiest way is to drag that file from my desktop or wherever into the left-hand side of Xcode's project window. And then I would see another window that says, do you want to move or copy this file into this project? So it'll be a very explicit process, and we will do that, but not with the simplest of programs, since they have just single files. So an example that illustrates here, hopefully, the notion and the power of pointers. And if not all of this sinks in the first time around, not to worry. The nice thing with Objective-C is that we can kind of start to take a lot of this for granted at first, but you're going to see the star, the asterisk, all over the place in sample code and the like. So this will hopefully give you a sense of what's really happening here. So here is a very simple program I wrote, and it starts as follows. So at the very top, I have a bunch of comments in green. I scroll down, I have standard.io.h. It turns out that that function printf that we've been using has been declared in a header file called standard.io, standard input output.h, and this was written many years ago by someone else. So this header file's presence here means include the contents of that header file so that when I compile this program, main.c, Xcode knows what in the world I mean by printf. So it's much like an import statement there. It's like a copy-paste of this file inside of my own file. Now, this is not necessary in Java, but is necessary in Objective-C, in C, C++. The compilers for C historically have been kind of dumb in this sense, in that if you don't tell them a function exists, they're not going to realize it in time if that function does exist, but is at the bottom of your file. So the fact that I've mentioned the return type here, void, the name swap, which is going to be a function I'm going to write in a moment, the parameterization of it, a and b, semicolon. This is not the implementation of this function. It's the declaration only. And this is just a hint to the compiler saying, not ready to implement this yet, but expect it to be implemented somewhere in the file. Java's a little smarter in this regard, whereby it doesn't matter if it's the last thing you wrote in the file. The parser will read through the whole file, realize, oh, swap's down there. With C, Objective-C, at least with these types of functions, you've got to be much more pedantic and just tell it what to expect. So that's all that is there. But let's look at main. For these programs, at least for now, none of them are actually going to take command line arguments. So even though there's this mention of argc and argv, like in a Java main method, we're not going to use them for now. Everything's hard-coded for demonstration's sake. In fact, very underwhelming example thus far. I have an int called x, setting it to 0, an int called y, setting it to 1, and then I'm just very happily printing x is %d, \n. So I'm just borrowing the trick I learned a moment ago, and I'm substituting in for %d, the value of x. Y is %d, substitute in the value of y. So if you do mentally compile this, when I run this program, I should see 0, then a new line, then the number 1 with a new line. So 0, 1. That's all, with x is and y is in front of both of them. Now I just happily say this, swapping x and y ... I'm making this very bold statement that I'm about to swap the value of these variables. Well, what comes next? A function call called swap, passing in x and y. And just conceptually, I haven't seen the code for this yet. I'm going to hope that swap is indeed going to swap these values. And then I happily print success. And I see x is %d, substituting in x. Y is %d, substituting in y. And that's the end of this program. So let's go ahead and run and compile this. I'm going to, at the top right, click this little icon that shows a bottom area, and that's going to open my console or debugging window down here. I'm going to hit run at top left, and now I see down here a whole bunch of non-bold output, but the interesting stuff is at the bottom. X is 0, y is 1, swapping x and y, success. Clearly not. All right, so this is a failure. So, okay, maybe I'm just an idiot and I forgot to implement swap, or it's just not implemented correctly. So let's take a look. I'm going to scroll down in my code to the swap function, and let's take a look. Swap takes an int a, an int b. These again are primitive, so this is generally 32 bits or 64 bits, and the same here. I'm declaring a temp variable, temp, of the same type, so that looks correct. I'm storing inside of temp the value of a. I'm then changing the value of a to be that of b, and then I'm putting in b what was originally in a, but is copied in temp. So these 3 lines of code, once executed at this point, have a and b been swapped. Right? It's kind of like programming 101 when you were first learning some syntax. And at this point in the story, those values variables were in fact swapped. The problem is this function ends, curly brace. It returns nothing, void. So now this function is completed its thing. The control flow returns to the main function at top, where at this point in the story, x and y have not actually been materially affected. Because at least in C, in C++, in Objective-C, when you pass in arguments in this parenthetical way to a function, unlike Java, which passes most everything around, at least classes and objects, by reference, when you have no mention of star and no mention of any other funky syntax, what you're passing to swap is the value 0, comma 1, but copies of 0 and 1, copies of those 32 or 64 bits. So A and B, when that function swap executes, have the identical set of bits inside of their memory. It successfully swaps the contents of A and B, but A and B are now distinct variables in RAM, distinct chunks of memory. So you've swapped 2 variables wonderfully well, but you swapped the wrong 2 values in memory. So how do we solve this problem? Well, at least right now, there's no solution that's an easy fix in this file. But what I can do is this. You know what? If the problem conceptually is that I'm passing in copies of x and y, and thereafter calling them a and b, well, clearly that's the crux of it. Let me pass in the actual values of x and y so that x is synonymous with a and y is synonymous with b. Well, how do I do this? Well, in Java, anytime you're passing objects around, you again pass them by reference. You tell some function where they can be found in memory by way of those things called references. Well, in C, those references are called pointers. And so what I'm really going to pass in is the address of x and the address of y. So if this little finger-based rectangle is RAM, all 2 gigabytes of my RAM in some computer, and x and y happen to have been put here and here, what I really want to do to swap is not pass in copies of x and y, 0 and 1. I want to pass in the addresses of x and the address of y so that swap itself can go visit those same addresses and find and change the values there. So just to make this a little sillier, if those familiar with languages other than C-based languages, if x lives at 33 Oxford Street and y lives at 34 Oxford Street, I don't want to pass in 0 and 1. I want to pass in 34 Oxford Street and 33 Oxford Street so that swap can go visit those same addresses in memory, change the bits, and then success will be true. So how do we go about doing this? Well, to tell a function that you want to take not a value, but an address, you prefix the variable's name or the parameter's name with a star. I'm going to do the same thing with b. And now, for now, Xcode realizes this guy does not know what he's doing just yet. But that's OK. Now I have to change the signature of this function. And I'm saying take a pointer to a. Rather, a pointer to an int. Call it a. A pointer to an int. Call it b. And now this is problematic, but I am a little scared of trying to fix this all at once. Let me first now change the calling convention. If I want to pass in two values here, x and y, I can't just pass x because that's 0. I can't just pass y because that's 1. I need to pass the equivalent of 33 Oxford Street, and the syntax for that in C is the ampersand. This says get the address of this variable, 33 Oxford Street, and pass that in instead. Now I change this other thing to an ampersand here, passing in the address of y. So that's good. Xcode is cautioning me for just a moment here because it hasn't realized I fixed it down here. So let's fix this now. All right, so now I don't want to store in temp the value a, because at this point in the story, if I've told the story well enough, what is inside of a? So an address, so the equivalent of 33 Oxford Street, not the number 0, the address. So how do you tell C to go to this address? How do you say visit 33 Oxford Street? Well, this was an unfortunate syntactic choice, but you again use a star. But it means something a little different here. It means go to this address, not this is an address. Now, if I want to change the contents of A, I need to change this, and this, and this. And if you're following along okay here, is temp, does he need to be changed to have a star in front of him too? So no, with temp, I just need a chunk of RAM to put the contents of those variables x and y in. So he does not need to be a pointer. He can remain actually a value there. So let's go and scroll back up to where I called this function. And I claim that I'm passing in now the variable x and y. I'm going to go ahead and, what's going on here? I thought I fixed all this. Yeah, exactly. So notice that I did fix it down here, but remember, oh, interesting, conflicting types for swap. Where is that other type declared? At the very top of the file, I have to, again, very pedantically tell the compiler, hey, expect two pointers, not two variables. Now, if you wait enough seconds, the errors will resolve themselves. If I go ahead and click Run Now and click down here, we now have successful swapping. Yes?
So did you have to call those A and B within the function? I mean, is there a lexical scope, or could you just, I'm not used to this.
Very good question. I could have called A and B x and y, or foo and bar. You can actually use the exact same names because each function is in its own scope, its own stack frame. So we could have used the same names. I chose A and B simply to make it more clear that these are actually distinct chunks of memory. Their contents are simply different based on the failure implementation or the success implementation.
So I mean, the A and B and the function swap are local to that.
Exactly. So essentially the rule of thumb in C, and we'll see in Objective-C, is local variables and parameters are scoped to the actual function or method in which they are defined. So really quite like Java in that case. Yeah?
Before main, you are declaring swap.
Okay.
Replace swap for the function that you have after main.
Yes. Yes. So if you would like, you could certainly avoid the redundancy of the prototype. And you know what? If I'm going to call swap, if I'm going to use swap in main, I could just define swap above main. Generally, as a matter of style, most people tend to put main at the very top of a file, so that kind of violates that convention there. And you can certainly contrive examples where foo calls bar, but bar might want to call foo or the like, where you actually can't order them in precisely the order in which they'll get invoked. So in that case, you need to resort to the prototypes anyway. And to be honest, as a matter of convention, a C programmer would typically appreciate knowing at the top of a file what functions are declared so that you then know what to expect elsewhere, even though it is admittedly redundant. Yeah?
Do you need interfaces then?
Do you need interfaces? C does not have interfaces.
This is basically its own interface.
It is. So if you wanted to share this code or the functionality you're writing with someone else, the convention there is to declare your functions in .h files, and someone else then could include that .h file, and only by reading the .h file would they know what functions they could use. That is your API, if you will. But C predates a lot of these more modern conventions of interfaces and the like. But Objective-C will introduce something akin to that. Any other questions here? All right, so that was pretty quick, but know that in your printouts are both the first case we saw, swap failure, and even though I changed this manually here, there's also a copy in your printouts called swap success, which is the correct version of that function. And the takeaway for today, we're not going to rely on pointers all that heavily, but certainly understanding conceptually how they work is useful for us. Let me point out one other example quickly. This one is called getInt, and I'm going to go ahead and open the project here. Called getInt, which is alphabetically among your printouts as well, just to illustrate one other role these pointers can play. In this code here, we just have a main function. It's quite simple. And the role of this code here is to ask the user for an integer. Similar in spirit, frankly, to Java, it's not as easy as would be ideal to get input from the user, at least at the command line. And my code here is not nearly as robust as it should be. I am assuming that my user is going to behave and give me an integer. But let's assume a friendly user for the moment, just so that if you skim through some of the other C sample code that we've given you tonight for reference, here's a function called main that declares an int n. That n is going to store a user's input. I say with printf, enter an integer. And then I say scanf, so scan a formatted string. What am I going to scan the user's input for? %d. So just as %d can be used to format output, it can be used to format input's expectations. So in a moment, the user is going to have the opportunity to type something at the keyboard. Assuming the user actually types an integer, scanf is going to recognize, oh, thanks, that was an integer. Where is it going to put that integer in memory? Well, at the address of n. So here's just another very simple example where you might want to use pointers, because if I just passed scanf, the variable n, not useful. Because then scanf would get a copy of n. It could change, if you will, those bits. But then when scanf returns, the original bits will remain unaltered. So if scanf wants to put something in n, we have to tell scanf the address of n. Ampersand is address of. And so here's yet another use, not just for the arbitrary swap example, but for where it's genuinely compelling to actually unpower a function to mutate some value without even having to rely on return values. In fact, this is just, I'm not using the return value here at all. And then this printf statement just says thanks for the %d, and that's going to be whatever the user there inputted. And just so you see how this is run, I'm going to click run. My console window at the bottom will open up automatically. And if I make it a bit bigger, notice that it's not done running. I literally have a blinking prompt inside of my debugging window, so I can go ahead and type 123, enter, and now I'm going to be thanked for my 123. So you can interact with the command line down there, which will be useful not so much for writing command line iOS applications, but for debugging command line iOS applications. We can navigate the call stack, as we'll see with this tool called GDB. All right, so a quick whirlwind tour through some features so that in a little bit we can now start to leverage a higher level language of Objective-C. So we won't spend time on some code examples here because it would probably get pretty dry quickly, but you'll see very soon that C, like Java, supports kind of the basics when it comes to Boolean expressions. So all of the syntax with which you're probably familiar already, pretty much the same in the world of C, and in turn Objective-C. So Booleans are supported. Conditions, ifs and else exist. You can nest them just as you can in Java. You can have if and then a statement. And if you have just one statement, you don't need the curly braces. If you have multiple statements, you do need the curly braces. So syntactically, C is very much like Java, or really, Java is very much like C. So it won't be too much to scare there. Loops, sort of old school style, for, while loops, do while loops. Pretty much in all three cases identical, as we'll see to the world of Java. But then two features that are worth pointing out here because they'll be useful before long. So C has this notion of an enum, an enumerated value, and we might use this for the following reason. I'm going to go ahead now and open in Xcode a project called enum, which is also among your printouts. And as an aside, lest I be going too fast here, an Xcode project generally has a ridiculous file extension, enum.xcodeproj, P-R-O-J, and then nearby in that same folder is probably another folder, and that's where all the source files are, your .c files, your .1 files, and many other files we'll soon see. So anytime I say open an Xcode project, you don't open the folder per se, you find the .xcodeproj file, which itself is kind of a special package that's got a lot of stuff inside of it. But it'll have a bluish icon like that. So I'm going to open up enum. And notice this. So I'm going to scroll down quickly first to the main method, the main function, to see what's going on here. It's going to get a little more sophisticated, but what we'll see later on tonight is that we can rewrite this code much better with an object-oriented language, because you'll see that I'm clearly going to be encapsulating or trying to encapsulate some data inside what C calls structs, but Objective-C and something like Java can give us a more powerful and robust way of encapsulating information. So here's my function. Some of the syntax is going to look new, but we'll tease this apart in just a bit. So here's a chunk of code related to someone named Alice, a student named Alice. I am declaring what appears to be an object, but that's not quite the right jargon yet, an object of type student whose name is going to be Alice. So that's a variable of type student. C does not have a data structure called student, but I can define one, as we'll see in a moment. Alice.name is going to be quote unquote Alice. Alice.gender is going to be female. And then I'm passing Alice to a function greet, and it's going to say hello Alice or something like that. So what is a student? What is a name? What is a gender? Well, let me scroll back up in this file. There's a prototype. So even though we haven't looked at the code implementing the greet function yet, it's down later in the file. But for now, assume it just says hello to Alice. Let's scroll up further in the file, and there's my first data structure. So in C, you have the ability to define what's called a struct, structure. This is not a class, because a struct can only have, essentially, data inside of it. It cannot have methods. Now, that's a slight white lie, because a language like C supports what are called function pointers, and you can pass functions around by their addresses. So technically, you could put in a struct the address of a function and then call it, but at this point in the story is when higher level languages started to be implemented to make that a more restrictive or well-typed process. So here is some syntax, and we won't use this too much, but you'll see in the documentation that there are some structs, especially with graphic stuff where there are fields like this defined. I'm going to say define the following type with the keyword typedef. It's going to be a struct, a data structure, and the curly brace says here comes the contents of this structure. Char star name. So whereas in Java there's a data structure or class called string, C does not have classes, but it does have char star, which for tonight's purposes assume that using this thing called a pointer, you can implement the notion of a string, which is character, 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 just by remembering the address of the first character. Hence char star, give me the address of a char. That's the address of the first character in a string. Thus we're born the notion of strings. But it's much lower level in C than in Java. Genders. I don't know what genders is yet. It's not a primitive type, so it must be declared elsewhere in my file. But apparently a student, as defined after the curly brace, has a name and has a gender. So what is gender? Well, let's scroll up. Well, you could declare a bunch of constants in your file, just like in Java, class constants or the like, where female is 0 and male is 1, or whatever numbers you want to initialize those constants to be. But if you don't really care about the underlying values that you give to these constants, you just need a capital female and a capital male. Who cares what values are used underneath the hood? Enum is powerful, because when you say typedef enum, female, male, based on the order in which you list your capitalized, by convention words, female is just automatically going to be assigned by the compiler a 0, and male is going to get a 1, and the type itself is apparently called genders. Now, alternatively, just to show you why this is helpful, even though it's a small example, if you want to declare constants in C, generally you would do define a constant called female and initialize it to 0. Define a constant called male, initialize it to 1. You could do this, but the problem is for more interesting examples than just male, female, which only has 2 different values, if we had a data structure or some program where we really needed a bunch of constants, this just gets very tedious and difficult to maintain, especially if you're trying to be anal and keeping things alphabetized, then you have to renumber things. It's just not interesting coming up with arbitrary values yourself. Enum enumerates the constants values for you, so it's just a little helper feature. So we'll see that in use before long. Any questions on enum? Yeah? It is called genders, yes. Yeah?
What did you say about it being alphabetized?
Oh, so I was just kind of going off on some random asides. Like if I was really anal and if I had a third and a fourth and a fifth gender in this example, and I just wanted to keep them alphabetized, I would have to renumber all of the values. And this is just where it just why isn't there a feature to do this for me? Well, there is the point there. That's all. Yeah? Oh, yes. Relayed question.
Question, I guess.
No.
Think that
You will see them at times. So there are these different frameworks that Apple presents to the world. One's called Foundation, one's called Core Foundation. There's other frameworks in play. Some of them are C-based, especially the graphical ones. Some of them are Objective-C based. And so you will see quite often in books and online examples a commingling of C syntax as well as Objective-C syntax. So if we focused only on Objective-C, we would be remiss in that you'd start seeing syntax that's not actually Objective-C, but it's clearly integral to the program. So at least tonight the goal is exposure to some of this syntax, though most of the code we'll use in C will be Objective-C. Yeah?
But it's not about EM itself, but what are the different types of comments?
Good question. What are the different types of comments? C supports both the one-liners with / at the start of the line, as well as multi-line comments with /* and */. From the course's perspective, really these days, and you'll see in Xcode, the convention is almost always a // except for particularly long multi-line comments, but this is a matter of style. Simply be self-consistent at that point. Both exist. So we'll have a couple features left to toss in the mix, namely one, an array. So much like in Java, there is this notion of an array. And that'll be useful, especially as we start introducing some features of Objective-C. So let's go ahead and take a 5-minute break. We'll regroup, take a look at arrays, and then dive right in to Objective-C. Welcome back. So that was super fast. We spent 1 hour doing what most courses spend an entire semester doing. So it feels reasonable to pause for just a moment to just address any sticking points. Anything where there's a conceptual hang up here, let's answer any questions you might have. But rest assured, the more we see this, and this isn't the only time you'll see it, it'll sink in. We just need to lay some foundation. Anything at all? Yes, yeah.
Sorry, could you say again how you would read the characters ampersand and the two different...
Ampersand is address of. So if x is an integer and ampersand x is give me the address of x.
And asterisk, there are two different meanings for that?
It depends on context. So in a functions declaration inside the parentheses, when you're mentioning parameters, if you say int x, that means this function takes an argument of type int, call it x. If you instead say int star x, that means this function takes an argument that's a pointer to an int, call it x. So inside of those parens, star x means int star x means pointer to an int called x. Now, the conflation of that syntax then happens inside the body of the function. If you subsequently say star x, that means go to x. X is an address, presumably. Star x means go there. So that's, I think I can safely say that's it for now for the crazy syntax. Yeah?
You mentioned that Xcode no longer uses GCC, uses this LLVM.
Correct.
I've used GCC a lot in the past. What's the difference with LLVM that I should be worried about?
Worried, not so much. So this is actually an open source initiative that I think Apple has been a large part of. I think you can go to llvm.org. I think it started as a university project. But in short, they've replaced part of the compilation process with LLVM. Part of it still uses GCC. In fact, at the command line, you can still see LLVM-GCC is the compiler. And essentially using part for the front-end compilation, where they take the source code to some intermediate language, and then a different part for the back end, where it actually takes it down to zeros and ones or machine instructions. You can still use GCC, and if we actually spend time on those cryptic looking build settings, you can change this. But supposedly, especially if you read the fancy marketing on Apple's website, LLVM in its current form is touted as being faster and more efficient in terms of the object code it outputs, and the error messages tend to be a little more user friendly. But shouldn't have any material differences. But if you've got a lot of legacy code, I imagine you could see warnings start popping up or problems. Yeah?
I noticed C++ was there.
Yes.
Is that something that we can leverage for our projects? Or?
So you can leverage C++ for, say, the student's choice projects if it's warranted, especially if you're integrating with some third-party API or you're using some framework that's C++ based. Much of what's in the Cocoa framework, the Mac framework, is either C based or now Objective-C based. But so I would say, short answer, yes, if it actually makes sense. But for the most part, anything we do with iOS specifically starting next week will almost always leverage Objective-C, except for some more graphical things. So in short, just persuade us in the proposal that this is warranted and not just more familiar, for instance. All right, so a couple more features, and again, we'll pause at any point with questions, but let's actually look at what this greet function was doing. So if you recall, we had our enum example. This is the enumx project. We're looking at main.c in that project, which is among your printouts. We looked at the notion of an enum for constants, the notion of a struct for a data structure, talked about prototypes. We looked at main. The only thing left in this file is that greet function. So what is greet doing for us? Well, greet is apparently taking a student structure as its argument. As an aside, for the learned in C, could have been passing this by pointer if I wanted to, but I wanted to keep it simple. I'm just passing a copy of the student in, even though it's a little more inefficient. But notice what I'm doing down here. I'm saying hello, comma, %s. Recall that %s is a placeholder for a string. Hello, string, \n. So the first string I'm printing is apparently title, whatever that is. Come back to that in a moment. And s.name. So if I want to get inside a struct, to get a field inside of it, s.name, s being the student, name being the char star field. So that's printing its name. And this is syntax you've probably seen from some other language, the ternary operator, whereby I'm assigning to a variable called title. It's of type char star, but for tonight, waving the hand at that, char star equals string for tonight's purposes. So title is going to be either quote unquote Ms if s.gender equals female, else it's going to be Mr. if it's not equal to female. So it's just a slick one-liner because I wanted to come up with a string, Ms. or Mr., and then plug it into my printf line. So if I run this code in the end, it's not going to wait for any input from me. If I look at my console output here, hello Ms. Alice, hello Mr. Bob. Because inside of my main function, the only thing I did after declaring those two objects, or those two structures, was greet Alice and then greet Bob. That's it. All right, so let's round off some of C's features. Well, we have the ability in C to do something with arrays. And this is something we will see in C is quite limited, so we'll spend quite little time on this because in Objective-C, we'll actually have more proper vectors and the like so that they will dynamically resize if we actually need them to. But you will see, especially if we look at some core graphics stuff before long, that occasionally C-based arrays are indeed useful. So here's a program. Here's a project called array. It's among your printouts, and the file is called main.c. And what we have here is nicely commented code, int n, so give me an integer, tell the user enter number of exams, scanf, recall we saw that trick earlier. This is just a poor man's way of just getting an integer with no error checking, so do as I say, not as I do here, but we'll never do this anyway with iOS. Allocate memory for grades on the stack. There's different ways to allocate memory in C. This, at the moment, is the simplest. I'm simply saying give me an array, as implied by this square bracket notation, of ints. Call it grades. How many ints do I need? N. So whereas in Java you'd have to use new and you'd have to put the square brackets on both sides of the assignment operator, in C, at least for this approach, this suffices. This will give me n ints in an array called grades on the so-called stack. This is in contrast with something called the heap, but I'm going to wave my hands at that because we're going to soon move on to Objective-C memory management, which will take us through the rest of the semester. So who cares about an array? Well, this little program is just a little simple toy that I wrote because I wanted the user to tell me all of their grades for the semester, and then I'll do something with them, but I got bored at that point because I didn't need the grades for anything, so then I just return. But it demonstrates syntactically how we can use arrays. Here's a for loop, much like Java, and we promised that was coming. So declare an int called I, set it to 0, do this so long as I is less than n, which is the number the user typed in, I++, enter grade something of something. So this is just a pretty way of telling the user, enter grade 1 of 3, 2 of 3, 3 of 3, and then how do I actually get it? I use scanf, and same deal. I want to put it into the ith location of the grades array, so I use the address of to put it in the right place, and that's it. So in short, this syntactically is the approach to arrays in C. Notice we're not using the new operator. We're simply using the square bracket parenthetical, saying give me this many grades. All right, so how do we actually allocate memory if we need it dynamically? And then we turn our attention to the Objective-C type approach. So back in the day, when you wanted memory, you had to tell the operating system exactly how much memory you wanted, and you better not abuse it. You better not overstep your bounds. You better free it when you're done so you don't have memory leaks. And if you've ever used buggy software, it quite often reduces to some kind of memory management issues. And we'll see, thankfully, in iOS, there are some tools that you get with Xcode that will help you profile your code and even track down memory leaks, especially in the world of the iPhone, which does not have a feature called garbage collection. It's really the burden is on you to minimize your memory usage. And in the event that your user is crazy about opening up this app and this app, now that there's sort of the illusion of multitasking, well, sometimes you might get an event, essentially a message saying, this user really needs all the available RAM. You better start freeing up some of your memory. So we'll see, too, that we might be commanded to free up memory, even if we'd really rather hang on to it. So more on that to come. But in the world of C, you malloc memory, memory alloc, and you free memory. And I'm going to wave my hands at how that's done, because we're not going to need to do it for Objective-C. But you will see in your malloc project among tonight's examples some sample code, if curious to see it in actual context. Any questions on C? I realize we spent very little time on that language. Yeah? Uh-huh. Uh-huh. Good question. If I had reversed the order in which, in my enum example, I had declared these structures, no, I don't think so. It's a good question. I'm fairly certain not. We would have to give a hint to the compiler that it was coming. You can, so that's a good question. Actually, I actually don't remember this one, so let's just try this and see what happens. Yeah, so already Xcode is whining that this. So I would do something very similar to the prototype syntax saying, this is coming. And so long as you enumerate what's coming at the very top of the file, it doesn't matter later the order in which you actually do it. So these problems are indeed avoidable. Anything else on C? All right, so now Objective-C. All right, so to be honest, though we spent just about an hour on the language C, what's nice about C is that it's actually a pretty small language. And though I'm sure I did many disservices to the language there, we kind of covered most of the language's features, both syntactically and with the wave of the hand, even more sophisticatedly, things like memory management and the like. So what you did not see, realize, are things like classes or exceptions or methods, notions of private and public. A lot of these things that you've probably taken for granted for some time in higher level languages, certainly Java. So Objective-C, which is used predominantly on the Mac platform for Mac OS applications, these days for iPad, iPhone applications, uses this language called Objective-C. And as the objective implies in it, it adds some object-oriented properties to the language otherwise known as C, but some other features as well. I'll say syntactically, this is a bit scarier, certainly at first glance, than a lot of languages in how you pass messages, how you call methods, how you represent things. But you'll see that most of what we're about to look at and we'll use for the rest of the semester is probably very similar in spirit to languages with which you're already comfortable. So here is Hello World written in Objective-C. So we'll tease this apart before long, but let me point out some salient characteristics here. We have some very similar structure to our C example, because again, Objective-C is a superset of C. So what do we have at top? Well, import foundation/foundation.h. So one of the challenges with learning Mac OS programming, iPhone programming, is that not only is there for many people a new language, Objective-C, there's also so many damn functions and methods and classes that exist, but frankly, that's akin to Java. I mean, frankly, if you've ever pulled up the default Sun Java doc for the language, it's ridiculously overwhelming, and most of us have probably never clicked through to all of those classes. Well, same here. There's a lot of code that's been written and provided by Apple that we'll scratch the surface of with various examples, but there's a good amount of documentation where you can go off and explore, certainly for your choice projects. Import is similar to include, but it's a little smarter. Import prevents the same file from being included multiple times and causing conflicts of sorts, but the idea is the same. Notice one thing too, we haven't seen this yet, but anytime you import a header file, which again has functions, declarations, maybe some constants, enum, structs, that kind of stuff, if it's in angled brackets quotes like that, it means it's installed in the system. It came with Xcode, came with the compiler. If you have double quotes around your header file's names, that means you wrote it. So it's somewhere in your project folder within Xcode. So we'll see that distinction there. Int main, int argc, argv, pretty much the same as we saw before. And in fact, for iPhone programming, we're never going to touch that, really. In fact, we're never going to touch main pretty much ourselves, but it does exist to bootstrap the whole process. Even though in Objective-C and in iOS programming there's a main function, it's going to call a more interesting function, which will eventually be right here, that's going to kickstart the whole graphical process. So what is in the Objective-C implementation of Hello World? Well, generally, you use something called an auto-release pool. So we'll come back to this. But in Objective-C, you have to do a bit more memory management yourself, but it's a little more user-friendly. It's a little higher level than that thing called malloc and free. This auto-release pool is a convention that essentially tells the operating system, I'm going to need some RAM to put some stuff in. I don't know how much yet, but on occasion, I'm going to say auto-release this object when I'm done with it, and it gets put into that chunk of memory. So for now, it's copy-paste, but we'll spend more time discussing how and why and when you do that. NSLog, henceforth, is going to replace printf for us. Anytime you want to print something to the console, particularly for debugging purposes, development purposes, the little bottom window in Xcode, you're going to use NSLog. The nice thing about NSLog is that even though I'm not using the trick here, you can use %d, %f, and all of those same formatting tricks, which is why we introduced the origin of those, namely printf. But this @ sign. So it turns out in Objective-C, even though you might see occasionally, especially in older code, char star, the sort of old school approach to strings, in Objective-C, strings are their own object called NSString. Capital N, capital S string. We'll see this in print before long. When you want to write a hard-coded string in an Objective-C program, weird though it looks, it's an @ sign, then a quote, then the characters you want to write, then a close quote sign. So in short, anytime you see an @ sign in front of a string, that's because it's a string object, much like in Java, but the @ sign says this is a string object, not a char star, not the more primitive data types. But for now, just take for granted that you need to use the @ sign there. Then there's this clever mention of draining the pool, the auto-release pool, but again, we will come back to that. So let's go ahead and take a look at this. If I go back to Xcode, one of the projects among your printouts tonight is Hello Object-C. I'm going to open this one. And all this is identical to what we just saw there. So in fact, let me see how I got to this point, just so that we're not taking much for granted. It looks like there's more stuff going on at top left. So let's see how I got there. So I'm going to close this and do it from scratch. But I am going to cheat by, actually, no, I'm going to leave that alone. I'm going to go to the File menu, New Project. I'm going to specify still. Today we're doing not interesting Mac programming, but we're not going to introduce a little glass screen yet. So we're just going to do a command line tool for now. I'm going to then say next. But rather than specify that this is C, there actually seems to be no Objective-C option, but indeed most of these are. Foundation means this is a program that will be written, presumably in Objective-C, but I would like you to include with the import statement and in the Project Explorer the so-called foundation classes, which is kind of like, this is an abuse of this is not a safe analogy, but like java.lang, stuff you just kind of get for free, similar in spirit to that. It's some framework code functions that aren't in Objective-C itself, but Apple wrote and are used in most Mac programs. Let's save that wherever. Now I get this cryptic looking build settings, but no matter, I'm going to ignore that. Let me blow up my window here and look at top left. So there's a little more. So it turns out in Objective-C, the convention is usually to call your files not .c, but .m for methods. So there's this distinction, and we'll come back to this before long, of methods versus functions, slight semantic difference, but for now they're pretty much the same thing. There's this .1 file, which is just this man page, and this is really uninteresting and ancillary to the course, so I'm going to hit delete. And notice anytime you delete a file from Xcode, you're going to be prompted. Do you want to cancel? Do you want to delete it? Or do you want to remove reference only? The implication there is that if you just want to remove it from this project but not erase it from your hard drive, just remove the reference only. But if you're done with this file, never want to see it again, delete the file there. So just know that that option exists. I'm going to go ahead and do exactly that. And now what else is up here? There's more. So this is again a template. It was a command line tool template, specifically using the foundation class. And if I click through here, supporting files, that's interesting, that's interesting, that's interesting. So there's more stuff. Let's look at main.m. Oh, we kind of already saw this. Well, in main.m is, and I cleaned up the white space, that's just the template code that Apple provided. So it's hello world. The funny thing is, as an aside, like there's weird style mistakes here, like this random lack of, this random additional white space there. The convention generally for most programmers in C is to put the star right next to the variable's name for some corner cases, but you'll notice that a lot of the template code doesn't do that, but a lot of the documentation does do that. So notice there are these slight differences that are really just mistakes or stylistic choices. But that's it for main. What else is up there at top left? Well, in Objective-C, you have this feature called a pre-compiled header, PCH file. And as you'll see here, this apparently is some clever, it's called a preprocessor directive. This is a little trick for importing atop any code file I write, this foundation/foundation.h file. And it's a precompiled header, and it has this special file extension because what Xcode is going to do for me is essentially copy and paste those 3 lines atop any files I write so that I have access to the so-called foundation classes in all of my code without me manually having to do this. So when I selected foundation from that little drop-down, what is it doing? It's doing a little something like that. It's just saving me the keystrokes of doing that manually. Yeah? It is a path. It's a relative path. It's in the equivalent of like user local include or the like. But yes, it's a relative path. And you don't need to worry about the preceding portion of the path. So foundation framework, this is just a special icon that depicts everything in the foundation class, or rather framework. And you'll see when I include foundation.h, it's essentially equivalent to including all these crazy .h files, which is apparently going to give me calendar capabilities, caching capabilities, coder capabilities, array capability. Array is going to be interesting, but this means I don't now have to remember, like in Java. I mean, that's kind of the headache in Java. You can either do import foo.star and kind of take in everything, or you can enumerate 20 different packages or classes atop your file. This is kind of doing that for us, a little more user-friendly like. And, yeah.
So in the main file, you didn't have to like declare the import, right?
I did not have to, but it did. But the precompiled header is going to help ensure that that's done automatically for me everywhere else. So this is where the one thing, frankly, that kind of hurt my brain when acclimating to some of these templates is that they just have made different design decisions that aren't sometimes necessary. And we'll see next week when we start using the tool formerly called Interface Builder, there's so many different ways you can do things. And the IDE or these templates sometimes get in the way of clarity. But in this case, you know, it was put here by default, but we wouldn't necessarily have to put it in subsequent files if we add more files, more .m files to our code here. All right, so if I run this just for good measure, not going to be very interesting, but indeed at the very bottom of my screen, I get hello world with some additional debugging information. We'll come back to debugging eventually, but that is indeed my first Objective-C program. So what more is there that we can use this for? Well, the memory management's a little more sophisticated in that it puts a little more control in your hand, well, takes a little control from you, but asks you to provide hints as you write your code as to when you need to keep something around, when you're done with something in memory. It's not going to be garbage collected like Java, whereby if you just kind of stop using foo, it will realize as much and go garbage collect, reclaim the memory from foo. Rather, in Objective-C, and writing iOS applications, if you don't tell the system by using something called release or auto-release that I'm done with foo, foo's going to stay in memory in perpetuity. And at this point, you know, the frame rate in your game starts to get a little slower if you're leaking memory, or you get warns that this application has to be killed or the like. So in short, managing memory very actively on iOS, even more important perhaps than desktops these days where you have more memory accessible and also garbage collection, but not in iOS. So more on that as we actually start writing code. So what are some new data types? In C, so everything you saw in C. So this was the advantage of spending just an hour on C. Everything we learned about C, you can keep using, or you'll keep seeing, because we're talking superset now. So we have ints and chars and floats and doubles and the like, but we also have some other data types, both built into the language and also into the framework here. So bool. Back in the day, true, false was apparently not the obvious decision. So yes and no are the two Boolean values in Objective-C. Capital Y-E-S, capital N-O represent true and false, 1 and 0 respectively. And the data type with which you declare such variables is all caps bool. There's ID. ID, for those of you with C backgrounds, is kind of like void star, but is a bit more useful, as we'll see. ID is kind of a generic data type, kind of like object in Java, capital O, object. It's sort of the most generic way of declaring a variable, and it actually has some value, and you'll see it throughout the documentation, but we'll see that in context before long. Nil 2, kind of similar to null, but null, all caps, is a 0 pointer. It's a bogus pointer address, a sentinel value. Nil is a little special in that you can actually pass things to it, messages to it, as we'll call them, and it will just not respond to them. Whereas null, dereferencing null, as a C programmer would say, tends to crash code. Trying to manipulate nil accidentally tends not to crash code. But we'll present that in context, so that makes sense. What are some of the data types you get with the Foundation framework, with all of those crazy header files we saw just a moment ago? Well, we'll see things like NS integer, especially in the documentation. At the end of the day, NS integer is essentially a type def. It's a synonym for generally a long or an unsigned long, or rather a long or an int. Depends on the system, 32-bit, 64-bit. These data types exist. They're not actually classes, even though they're capitalized in this way, but they're specified in header files so that you can abstract away from calling things primitives like int and long and float. NSPoint, NSRect relates to some graphic stuff we'll see before long, as well as size. NS unsigned integer relates to an unsigned integer. And so a lot of functions that you'll see documented in Apple's documentation won't say int or unsigned int. They'll return NS integer or NSU integer, but underneath the hood, those really are primitives. So they don't have methods or fancy features associated with them. NS stands for next step, and you can actually, I'll defer to online resources or Wikipedia, but there's a rich history behind Steve Jobs and Apple and Next Step, the company years ago, where a lot of this was inherited or bought from companies in yesteryear.
On iPhone and the other iOS platforms, what's the size of an integer native?
Good question. Generally, well, Good question. Generally, it would be 32 bits, even on a 64-bit architecture, but a long would vary in size. So a long would be 64 bits on modern Macs, but an int would generally be 32 bits.
For the mobile devices, is it
64.
Oh, 64?
Yes. I believe that's true. Let me double check that, but that's one of the reasons that these type defs exist. Don't quote me on that. Let me confirm before repeating. All right. So now let's start to introduce some features that just didn't exist in C alone, things that you might have been taking for granted with a language like Java. So I mentioned earlier that there are header files, .h files, and you put things like function declarations there, like printf is in standard io.h so that we, other people in the world, can use it. You can put constants there, but in C++, for those familiar, you might actually put your class declarations and define your classes. In Java, you might have interfaces defined in other .java files, but they're kind of separate from your actual methods and actual classes that you write. Well, in Objective-C, suppose that we want to actually introduce the notion of a class. And I'm going to propose that we discuss this in the context of a student. You can imagine a student being some real-world entity that would be nice to maybe model in code so that you can implement a grades database, a registrar database, whatever. So what's associated with a student? I can think of things like a unique ID number, maybe a name, gender, age, and you can come up with some random human-related properties for a student. So how do we start encapsulating this when we need to define a class? Well, how do you define a class? This is one of the first things that I think hurts the brain in Objective-C. There's not nearly as much symmetry with curly braces and the like as there is in Java, and there's sort of asymmetric keywords to start and stop things. But here we go. If you want to declare a class called foo, F-O-O, much like in Java, classes that you define implicitly inherit from the Java object class, which you don't have to explicitly write. In Objective-C, you would explicitly write that my new class foo descends from the grandfather of all objects called NSObject, next step object. So this is comparable to Java's notion of object, but we have to be more explicit. Rather than say class, you say @interface. This is not an interface in the Java sense. This is a new word for class. So at interface means here comes my definition of a class. It's going to descend from NSObject, and inside of my curly braces are going to be my instance variables. Anything that I want to associate with an instance of this class. So an ID number, a name, an age, whatever. Your methods, though, for whatever reason, do not go inside of the curly braces. They go after the curly braces, but before the keyword at end. So down here, I would declare all of the methods, all of the functions that I want to associate with the student and inform the world exist. So what methods might be associated with a student? Maybe some kind of a constructor, just to kind of fill a student object with some default names and ID numbers. Maybe a greet method if I want to empower a student object to greet the world rather than pass the student to a greet function. So we can come up with like arbitrary methods to associate with students. But the syntax for now is going to be that. You put your instance variables like ID and name inside the curly braces. Your method declarations outside the curly braces, and when you're all done talking about a student, at end. That is your class declaration. Yeah?
How do I define a static variable?
Good question. You can define, so you can't define a class variable as you can in Java. The closest approximation would be to actually revert to C and use the static keyword at the top of a file where you could declare static int x, and that would give you a static int that's only accessible within that file. You can mimic the notion of a class variable with, as we'll see, methods that just return a hard-coded value or the like. But in short, you have instance variables, not class variables in Objective-C. Yeah?
The namespace of the methods that you declare outside of the object, are those in the same scope as file, or are those somehow magically hidden from the rest of the file?
Good question. So the methods that you declare here would be accessible to any file that sharp imports this .h file. The instance variables, meanwhile, do have the notion of public, private, or protected. In fact, even though you don't see it in this canonical example, there are keywords like @protected, @public, @private, very similar in spirit to C++. And we'll see an example of this, but by default, these instance variables are going to be protected, which means that anything inside this class can touch those instance variables, or IVARs, and any child classes of foo can as well. But we could also change those to public or private. But again, we'll see an example in just a bit. Yeah?
Yeah, I was just going to ask the methods. Does it have a notion of public and private?
The methods do not. So there is no notion of public and private methods. There are ways to mimic that behavior using something called categories, which we'll glance at quickly tonight. But I think you'll find thematically here that Java definitely has some features that just Objective-C doesn't have, though you can kind of implement them for better or for worse. And we'll see some tricks over time. Yeah?
So are all of these functions in the heap or the stack? Can you things in the stack?
So good question. So neither really there. So the heap and stack in this case, so the memory gets managed for you in Objective-C, so you don't necessarily have the same conversation as you would in C about heap and stack. The code, so not so much germane unless you actually declare variables of this type, but even then the methods are implemented outside the scope of the thing called the heap and the stack, which are generally reserved for data, not actual functions, unless you dynamically define a function. But let me come back to a more advanced topic like that. All right, so instant variables. Just so you'll see the keywords here, and then we'll dive into some actual code. These will allow us to specify, much like Java, who can actually access certain variables. There is a notion now of a class method. So we'll see this in context in just a moment. But there's the notion of a class method, which you just call without needing to instantiate an object. Similar in Java to a static method. So a class method, static method, same idea. And you denote that in your .h file and your .m file, as we'll soon see, with a plus sign. By contrast, if you want to say you're declaring an instance method, a method you can only call once you've instantiated an object, so a non-static Java method, you use the minus sign. So plus is class method, minus is instance method, or static and non-static respectively. So same ideas. So even though we're introducing new syntax tonight, a lot of the same ideas, we're just kind of calling them something a little different. But we'll see this again in context in just a moment. So the most different thing about Objective-C that I think we'll see tonight is how you call methods. So whereas in Java you would typically say something like student.alloc to call a method called alloc associated with the student class, the syntax in Objective-C, as we presented in the first lecture this semester, is actually to use square bracket notation and to pass a message, as it's called, to an object in hopes that that object responds to that message. So to pass, in this case, I'm passing the alloc message to the student class in hopes of getting a response. In JavaSpeak, I'm calling the alloc method on the student class. And it's apparently, in this out of context example, it's a static method because this is capital S student, suggests that's the class name, not an object's name. But again, we'll see an example in a moment. Here's why we care about pointers now from C. When you allocate an object, so think of this as kind of like a constructor, like calling new in Java. It's going to look a little like this. So here I'm allocating a new object of type student. What I'm getting back really is the address of that object. I'm not getting back the object per se, because it could be a variable size depending on how much stuff I cram into that class. But I do just need to know one thing: where in memory is that object? Now, how do you talk about memory in a C program? Well, by way of pointers. So student is a variable that's a pointer to a student object. Perfect, because alloc is what's called a class method or static method that just returns to me, like a constructor would, an object of type student. So let's start using this. How might we go about doing this? Well, here now the code gets a little more interesting in that we'll start using multiple files. And I'm going to go ahead and do this. Make the first of my student classes by hand. I'm going to go ahead and start a new project. Again, for now, just because I want the simplest templates possible, I'm going to make this a command line tool. And I'm going to click Next. And I'm going to call this Student1. It's going to be Foundation, which means Objective-C, but give me some built-in Mac framework stuff. I'll save it wherever. Now I've got some template code, just like before. Just to be anal, I'm going to get rid of the man page thing, because we're not going to need it, and it's just going to distract me. So now I have really only one interesting file, main.m. But I kind of like to now start writing a program that somehow involves students. So I'm going to do something in this program ultimately like implement a student-related program. But to do this, I need to actually encapsulate the notion of a student. So I'm going to preemptively say, you know, it'd be really nice if I had a student class somewhere. Well, it doesn't exist yet, but I'm going to preemptively call it student.h. So now this begs the question, what and where is student.h? Well, I'm going to create it. So at the top left-hand corner, and there's different ways we can do this from the file menu or the like, but I'm going to keep it simple. I'm going to click on the group where I want to put this thing. I'm going to right-click or control-click. Notice there's a whole bunch of options, most of which we don't care about for now. I just care about making a new file. So new file. Now I get this little prompt here. And again, it's a little overwhelming because it's not going to give me a blank file by default in a typical IDE. It's got all these templates that will actually be useful because we don't have to do copy and paste ad nauseum. We can kind of start with some basics. So notice many, many, many different options here. I'm going to stick with Mac OS X. Next week, we'll start focusing only on the iOS stuff, but I don't want all the cruft from mobile software. So I'm going to choose a Cocoa application, which is a Mac app. I've got a class, category, protocol, test case. I just want Objective-C class. Keep it simple. All right, I'm going to click Next over here. What is this a subclass of? Well, it's got to be a subclass of something. I'm not making a fancy hierarchy, so it's going to be a subclass of the grandfather, NS object. And now I have to define the name. So I'm going to call it student.m. Down here, Xcode is realizing, ooh, you have a project called Student1 open. Guessing you want to put this file in that project, but just in case, I'll let you specify with checkboxes if you want to add it to the project or just create it out of context. But I want it in the project, in the Student1 group, so I click Save. All right, what do I now get? Well, very interesting. Even though I didn't specify it, Xcode decided, you're creating a class. You probably want a .h file and a .m file. So there we go. Top left, there's my student.h and student.m file. The order in which all these files are listed happens to be mostly alphabetical, but it's arbitrary. We can drag and drop those things to be anal, but it just put them at the bottom of the group list. It's meaningless for now. All right, so what's inside of a student? Well, apparently not much of anything initially. But we see the placeholders now for student. In fact, Xcode has assumed, you probably want to make these things private by default. But I'm not going to make them private by default yet, because I actually don't know how I would access them otherwise. So I'm going to get rid of this. And I'm actually going to make these things public. And what am I going to associate with a student? Well, just to be consistent with your printouts, I'll cheat off of our own handouts so that I'm the same. I'm going to give every student an age. And I'm going to give every student, and notice one of the powers of an IDE, as soon as you start typing, you start seeing all the possible things that start with that. You can hit escape to close it. But I want an NS string star name. And the star is important. Just like in Java, when you are manipulating objects, you're going to pass them around by reference. Java, they're automatically references. In C, in Objective-C, you have to be ever so explicit that this is going to be a reference to an object, rather a pointer to an object. So anytime you declare a primitive, I think this is a safe rule of thumb. Almost every time you declare a primitive, no star. Anytime you declare a variable that's meant to be of an object type, star. But there will be violations of that rule of thumb. But for now, that's the gist of it. All right, and that's about it. I'm going to just get rid of some superfluous white space there, but that's my student class. That is my .h file that's now included. I'm going to keep this simple. In my .m file, you know what? I don't really want any of this yet. I'm going to keep it ever so simple. Pretend you didn't see that template code, because it's not necessary. That's it, my implementation of a student. Now, a student right now is just a struct, right? This is kind of a newfangled approach to what we already had the ability for in C, which was structs. I'm not going to associate any methods, class or instance, with a student object. So now I can go ahead and do what? Well, inside of my main.m, because I've included student.h, now I have the ability to implement some kind of program involving students. So how might I go about doing this? Well, I kind of deleted, let me cheat and get this back. I kind of deleted a little too much. Notice I'm using double quotes up here and not angled brackets because it's my own file. I overzealously deleted my pool of memory, but I do want that for reasons we'll return to in the future. But let's go ahead and do this. Let me have a student called Alice. Give me a student object. It's going to be rather a pointer to a student object. How do I allocate a student object? Quick review. Not malloc, because now, with alloc, yes. So the class is called student. I want to alloc a method, close bracket. That is the comparable code to calling new and a constructor. Yeah? It is. It's given to you automatically. And let's see if we can't tease this apart. Here's your hint. Where is alloc coming from? NS object, from the parent class. So from NS object. So you'll see, and the reason I quickly deleted the template code, turns out you also get some other methods like init, which is like the second part of a constructor. In Java, you have the new keyword, which is like alloc. Then you have the name of the class and parentheses, which is the constructor. That's like init. So we'll see that the paradigm in Objective-C is that when you create an object, you allocate memory like new with alloc. And if you want to pre-populate it with variables like a constructor would, the method is called init. But I'm not fancy enough yet to know much about init, so I'm going to do the initialization manually. So if I want to now actually store inside of Alice's object her age, here's the one new piece of syntax for now, and it's borrowed from C. The variable is called Alice. It's a pointer, and the arrow says go to the field called age inside of this object. You can rewrite this with star notation, but I'm not going to impress us with that syntactical trick. Alice arrow age means go to the Alice object and follow the pointer, if you will, to her age data field. Now, how do we set the name? Well, I'm going to go name, and oops, I don't know what I'm doing. What's the bug? Subtle here. Yes, and notice Xcode is smarter than me. Let's see. Check this. Incompatible pointer types assigning. Incompatible. Notice this. This is what's kind of cool about the IDE. It will even fix it for me, which is useful for a programmer, but it's also pedagogically useful because it's not just some cryptic message you then Google. It will often try to help you fix your code for you. So now this is correct. This is creating sort of a static string, much like you would with double quotes in Java, and storing the address thereof inside of my Alice struct. How do I deal with Bob? Well, I can have a Bob object like student Bob gets student alloc. So that's the same as before. I can do Bob is going to be age 21. Bob's name will be Bob. semicolon. And now, what do I want to do with these two characters? Well, let's go ahead and call a greet method. Greet Alice. Well, it's a little problematic because I don't see any mention of greet yet, but we'll fix that. Greet Bob. And now down below, let's go ahead and implement greet. So let's say void, because this isn't going to return anything. Whoops. Pardon all the auto-completion. It's being a little overly helpful. Void. Call the method function greet. It's going to take a student as input. Let me zoom in. So it's going to take a student, let's call it S, but it's got to be a pointer now. It has to be a pointer now because we're passing an object around. How do I go about greeting? Well, nslog was the method I promised we'd use. Now I'm going to say @hello there. Okay, that's the equivalent of printf, but we're not inserting a name into there at all. So let's actually back up and say hello, comma. It's not %s anymore. Not to throw too many new features in here, it's %@. If you want to dynamically insert an NS string, which these guys' names are. So hello, so-and-so. I see that you are %d years old. All right, so there's my string. I've got one placeholder here. I've got another placeholder here. So just like with printf, I'm going to put the student and their field name. Sorry, it's wrapping font-wise here. And then S angle, how do I print out their age? Just age. So it's a little ugly with my large font size here, but that's going to do the equivalent of printf before. Notice this is an easy habit to miss. Even with nslog, it's not just quote unquote, it's an @ because nslog is defined as taking an NS string. What's my error here? Well, I actually know because I realized it earlier. I still need my prototype because this is still a C-based language. That seems to have fixed that error. Oops, this is just a stupid typo. Feels pretty good now. So let me go ahead and run this code. It's still a command line application, so I see the output here, and that's kind of neat. Hello, Alice. I see that you are 20 years old. Hello, Bob. I see that you are 21 years old. But I don't know what I'm doing. I've leaked memory. So anytime you call alloc, anytime you call a method we'll see called copy, anytime, and there's a couple of others that we'll trip across over time. Anytime you call alloc for now, you're asking the operating system for memory. You better give it back. Otherwise, if this is some fancy iPhone game that's running for a long amount of time, you're just consuming memory, but never freeing it up for yourself or for others. So to do that, you do not call dalloc. As an aside, and we'll see this more next week and beyond, don't call dalloc manually. There's really no context except one in which you would do it. But I do need to release Alice from memory at this point. And that down here, I need to pass Bob also this message called release. And this is a hint to the runtime that says, I am done with Alice now. I am done with Bob now. Maybe you're going to collect that memory now, maybe not, but I'm done with it, so you may collect that memory and because I no longer need it. So you're sending a message called release to each of those objects. In Java speak, you are calling the release method on Alice and Bob's objects, respectively. Yeah, question?
This last message you just wrote, doesn't have anything to do with the pool drain?
It does not. It's related in that both pertain to memory. In fact, the pool is reserved for something called auto-released objects, which we won't see just yet. But for now, know that there's a way of saying, I really don't want to deal with manually releasing this memory. Go ahead and release it when the time feels right. And you preemptively, at the start of your code, say, auto-release this when the time comes.
What I was trying to get to, without the pool drain, you can still have Bob release, right?
Yes, that's correct. So we're not explicitly using the pool here, even though we are using memory, for instance, to represent these statically declared NS strings. All right, so what more can we do here? Well, let's just present a bit of syntax so that we see it coming and know this. So now, let's suppose, this is very kind of bad object-oriented programming. I've, yes, encapsulated age and name inside of a struct, but I've provided no sort of access control. I've made those fields public, which is okay if it's only you using the code. It's super simple, but it's really not consistent with the idea of having getters and etceters or accessors and mutators, methods that control access to the contents of an object. So I'm going to decide, you know what, let me fix this, right? I remember my OOP principles. I'm going to now implement some getters and setters, and no longer make age and name public. They're going to go and become private or protected. So what's the syntax for this? Well, in our canonical example earlier of a .h file, I mentioned that a dash indicates instance method, and you would declare these in the .h file, and you then implement them in the .m file. So how do you declare a getter called age? And let me actually fix one detail so that it's consistent with your printouts, just as a matter of style, though this would still compile just fine. But now they're the same. So here's how you specify that a class has an instance method called age that returns an int. So that goes in the .h file. Here's how you declare a method or a setter called setAge that takes, to abuse the terminology here, an argument called age that is itself an int, but the setter itself returns void. Now, these are instance methods, and here's another one. Turns out we got this one for free, but in NSObject, there's an init method. But if I want to do some constructor-like initialization of my object, I can essentially override that method by declaring my own init method inside of student. Or, and now here's how you have what might be called explicit constructors. If I want to pass to this init method some arguments, much like you would an explicit constructor in Java, I can declare a method called init with name, colon, what do I want to pass in as a name? Well, an NS string star, an object. What do I want to call that thing? Name, for now. And I want to pass in an age, colon, of type int, and call it age. So this is syntactically where Objective-C is a bit weird. So this approach is, and the message passing approach is borrowed from a language called Smalltalk, but you'll see that the return types are pretty similar from other languages, including C. But the name of this method is actually init with name and age, kind of all in one breath. This is, we could call this most anything we want, but it's kind of an approximation of named arguments that you might have in when you pass a hash to a method or whatnot, but order is still important. So we'll see these in use in just a moment. How do you use these things? Well, we saw release already. Well, if you want to get a student's age, assuming you've implemented a getter and a setter, you'd say student age. If you want to set an age, you'd say student, set age, colon, and then the number you want to set. What about those things I keep calling constructors, but that's not really the right jargon for Objective-C? Well, if you want to initialize a student using whatever built-in behavior is in this init method, just call init. If you want to initialize Alice's object from the get-go without using the setters explicitly, but at the time of initialization, we could arbitrarily call this init with name at Alice and age 20. And now, assuming we implement that method properly, I should have a method, or rather an object in memory called Alice, inside of which is those two data members. So as a sneak preview, if we now run this code, let me go ahead and open my actual version of student 2, which is where we were going with this. Go back to tonight's printouts, student 2, Xcode project, expand this, and run the code. We will see that in the bottom here, I'm now using setters and getters, printing the same thing, but how am I calling them? Well, using precisely this syntax here. So I think we'd be remiss now if we didn't take this ever so slightly further. Let me close this, and as a sneak preview, I'm going to go ahead and make a new project. I'm going to tease us with the beginning of iOS and the beginning of the end of macOS, but I'm going to choose an iOS application. A lot of templates to choose from. Feels like it'd be really fun to start doing fancy navigations or whatnot. I'm going to keep it simple with a window-based application. I'm going to click Next. I'm going to make this my first iPhone app. I'll call this edu harvard.dce, kind of like a package name. I'm going to make this universal. Okay, it'll work on iPhones and iPad. Let's keep it small for now so it fits on the screen. Let's click this, save it wherever. So now it's a different template, but same idea. But ooh, this is starting to look sexy. Now clearly there's notion of physical hardware here, but we have some different files, a .h file, but my first iPhone app delegate, my first iPhone app delegate. Well, this is all nice and confusing. But let me click this thing, main window.nib, xib. We'll get to this. This kind of looks familiar. I feel like I need some more tools. Let me open this thing up here. Turns out down here, I'm going to go ahead and pick my objects. Ooh, little label. Center that. See you next week. Put this over here, and voila. notice the magic. I have not written a single line of code. But if I run this little iTunes-like application, you will see in just a moment our very first iPhone app. And that's where we're going next week. So we'll see you, see you then. Section will begin in a bit, and we'll see you otherwise next Tuesday.